Good morning. What's up? All good? Great. So today we will be solving the third question of weekly contest 392. So let's see what is this question. Minimum operations to make median of array equals to k. Okay. So you are given an integer array nums and a non-negative integer k. In one operation, you can increase or decrease any element by one. Okay, so you have been given an integer array nums and a non-negative integer k. And in one operation, you can either increase or decrease or any element of array by one. So we need to return the minimum number of operations needed to make the median of nums equals to k. Okay, so I hope you know what is the median. Median is just the middle element of the array. So we need to return the minimum number of operations needed to make the median equals to k. Okay, so let's see how we can solve it. So you have been given with this array and you need to make its median equals to k. So median is the middle element of any array or any sequence sorted in ascending order. Okay. So first of all, let's say we need to sort it 2, 5, 5, 6, 8. Okay. So now we need, what will be the median of this array? It will be 5. Now what we need to do is, we need to make its median equals to 4. And we can increment or decrement its element by 1. Okay, so I first thing which comes to your mind is that so we just don't need to do anything. We can just sort this array and then find its middle element and just do middle element minus k, right? And it will be one operation we need to do. Yeah, very good. But think like okay, so let's suppose you will decrement it by 1 and make it 4. So see, your sequence has distorted. It doesn't remain in sorted order now. So now it will become 2, 4, 5, 6, 8. And then again your median becomes 5. It doesn't remain 4 which you thought about. Okay, so it is not like that. You can just sort it in ascending order and then just find its middle element and then just do middle element minus k and then you will get minimum number of populations. No, it's not like that because if you do it in this way, then your sequence might get distorted and your median will become different in this, as you can see in this example, right? So what we can do so see what we need to do. We need to check for all the elements greater than 4 till median, right? Median is this. So what if we will decrement this element as well by 1? So it will also become 4. So whenever it again it will be sorted. So it will be 2, 4, 4, 6, 8. So now our median becomes 4. Good. So what we need to do is we need to decrease all the elements greater than 4 till median, right? So even if they are sorted after, they will be sorted after incrementing or decrementing the elements. Again, then we will be able to get our median as k, right? Let's see second example as well. 2, 5, 6, 8, 5 and k equals to 7. It is 2, 5, 6, 8, 5 and k equals to 7. Right. So first of all, we also need to sort it 2, 5, 5, 6, 8. Now what is its median? Its median is 5. So if we increment this by 2, so it will become 2, 5, 7, 6, 8. Cool. So your operations is 2 now. But see, your sequence of ascending order is distorted. So it will not remain like this. It will become now 2, 5, 6, 7, 8. And now your median has become again 6. See, okay. So that's why we cannot just took the median middle element and then just find the number of operations. So what you can do here is that if your middle element is less than k, so what you need to do is you need to check for all the elements after middle element which are less than k and also increment those elements as well. So what if we have incremented this by 7, this to 7 as well? So after sorting, it will also become 7, and then you will be able to get your median element, or we can say median as 7, right? So see, what was the condition here is that if nums of middle element is less than k, right? It was less than k. So what we were doing? We were checking for elements after middle element, right? We were checking for element after middle element till till when this element is less than k, because we don't need to increment this, right? Because they are not hampering our order. The element which are less than k are hampering our order, right? So we need to increment all the elements after middle element which are less than k. Okay, so this is one condition. And here what we were doing, here our middle element was, nums of middle was greater than k. So what we need to do is, we need to decrement all the elements before middle element which are greater than k, so that they should not hamper our order, right? So we need to apply two conditions when nums of mid is greater than k. So we need to decrement all the elements before middle element which are greater than k, and whenever our nums of mid is less than k, so we need to increment all the elements after mid which are less than k, because these are the only elements which are hampering our order. See, because 6 is less than k, so it is hampering our order. 8 is not less than k, so it is not hampering our order. So we will not increment it. Similarly, here as well, 5 is greater than k, so that's why it is distorting our order. 2 is less than k, so it will remain at its position and it will not distort our order. Right? So these are the two conditions. And whenever nums of mid equals to k, so we don't need to care, we can just return, because it is already equals to k and we are doing it to make it equals to k, so we don't need to perform any operation. Okay, so this is the case for odd length string. So what will be the case for even length string? So what is, let's suppose if we have 1, 2, 3, 4, 5, 6, yeah. So generally in even length case, median is the average of the middle two elements. But see here in this example, we have been given with 6 elements and we need to make median equals to 4. So see, here they are taking the second middle element, because now we need to make median equals to 4 and the second middle element is already 4. That's why they have given us output as 0, because we don't need to perform any operation. So we don't need to write another case for even length, because they are considering the second middle element. Because see, here length is 6, right? Here length is 6 and 6 by 2 is 3. So 0, 1, 2, 3, 4, 5. And they are considering this second middle element. And here also length is 5. So 5 by 2 is 2. So 0, 1, 2, 3, 4. So yeah, we are just considering the middle element and not doing anything else, because if they were considering the average of these two elements, then there might be something different here. But as they are just considering the second middle element, so we don't need to do anything in this. So let's see how we can code this. So first of all, I have declared a result variable and then store the size of nums in n and then sort it. Okay, and then find the middle element, right? If middle element is already equals to k, then we will simply return our result. We don't need to do anything. And if middle element is less than k, so what we were doing when middle element is less than k, this was the case, right? When middle element is less than k. So we need to check for elements after middle element till they are less than k, right? So we need to check after middle element till they are less than k, right? So we need to add k minus nums of y because we need to increment those elements to k minus nums of I times, right? Good. So we need to check for elements after middle element, and whenever we have nums of mid greater than k, so what we were doing? We were checking for elements before nums of mid till nums of I is greater than k, right? Till nums of I greater than k and before mid-i, right? So we need to also implement this check like I should be greater than or equals to 0 and I should be less than it. And then simply adding nums of I minus k in our result. And at the end, we are returning the result, right? So what will be the time complexity of this? So as we are just as we are sorting this array, so it will be n log n, and then it will take off maximum of big O of n in worst case, or we can say n by 2 because at mid we will be n, and either we are checking for the front part or back part. So it will be n by 2. So, but overall time complexity will be big O of n log n. And as we are not using any extra space, so it will be big O of 1. But as sorting takes an internal complexity of log n, so its space complexity will be log n. So this was all for this question. I hope you get it. If you still have any doubts, you can surely post in the comment section. I will try to answer them. Till then, bye bye guys. See you soon in the next video.